Hello, my name is Vaibhav and this is my submission for full stack developer case study. I developed a mini operation ERP system focused on inventory management and operational workflow. The application manages inventory across multiple locations and supports three main business operations: work orders, internal transfers, and customer orders. The application supports three roles: admin, operations, sales, which role-based access control. The technologies used, the architecture of the application is the React for front end, which uses Axios to make requests to our backend servers of Express. We use JWT for authentications and authorization. We use Postgres PG to connect to our database. For technologies, we have used React 18 White Router, React Router, Axios. For backend, we have used Node.js, ExpressFi. Database is connected by PG. For authentication, we have used JSON Web Tokens and bcrypt.js. Security is done with the help of Helmet and Cores. We have five built-in test runners. We have implemented roles and permission as following. We have three roles: admin, operations, and sales. And these are the applications, and these are whether they can perform or not. For example, all three can perform login. All three can view inventory and available stock. Adjustment can only be done by and operations, not by sales and such. Uh, After that, let me show you our this application is currently hosted live and is available with the help of render. This is currently the application running on deployed link. I have deployed it in render. Uh, So as you can see, both our front end and back end are hosted on render. Our database is also using a render Postgres SQL database. Coming to our database schema, we have a user that manages authentication and roles. Then we have categories that organize items. Items can have multiple branches. The inventory table is the core of the system. It connects an item, location, and batch and stores physical and reserve quantities. After that, we have inventory transactions, maintain a history of inventory changes and include key to help prevent duplicate operations. Work orders are connected to location, item, and assigned users. Internal transfers connect source and destination location and track the transfer status. Finally, customer orders are connected to the users who created them, while customer orders items cannot connect orders to specific inventory records. Overall, the schema is designed around keeping inventory operations traceable and maintaining clear relationship between operational entities. This is our login flow. Login page uses post API auth login, which decrypt password comparison, access tokens plus JWT return browser local storage, Axio sends authorization plus bearer, which is access token. Uh, Following are our auth endpoints, login, refresh, logout, and me, which is bearer token. This is our API reference point for Postman setup. Uh, for Postman environment, we have to set a base API, access token, and refresh token. This is our API endpoint table where we have methods, endpoints, allowed roles, and a request body summary. For example, we have get meta items, which any signed in users can accept. It does not have any body. These are examples of our APIs. We have API errors 400, 401, 403, 409, 500, etc. We have five automated testing, cannot reserve beyond available inventory, cannot transfer available inventory, destination quantity changes only after receipt, train transfer cannot be received twice, unauthorized sales user cannot create transfer. Now let me show you our tests running. So you can see it is connecting to our database. First test has passed, second test has passed, third test has passed, fourth test has passed, fifth test has passed, all our five tests has passed. This is the file that stores our uh, tests. And as you can see, it uses the base API of my backend. It also uses env to, which stores credentials to my Postgres database. Let me give a quick overview of our code. Here we have a database.js which imports the PG to connect to our Postgres database. env.js handles our envs. Here we have our controller files which control the internal logic. We have auth services which handles our authorization and authentication. The most important file is server.js, which is entry point of our backend. It configures middleware API routes and starts the server. Other than that, we have auth services, which are primarily responsible for verifying the JWT and identifying the authenticated users. The authorization middleware then checks whether the user role is allowed to perform the requested operation. DB helper.js is a database layer that manages Postgres SQL connection pool for critical operation transaction. Help us ensure that either the complete operation succeeds or the database changes are rolled back if an error occurs. Then we have uh, our controllers. For example, we have a transfer controller that manages the requested dispatch and received workflow. We have work order controller that handles material requirements and shortage calculations. We have an inventory controller that handles stock operations. Customer controller handles and validates reserve inventory. For front end, we have all our pages here. For example, uh, our login page, our inventory page, our transfer page, our work order page, uh, our these are all our pages. API JS configures and centralizes the Axios request while the authentication context manages the current user and the application state throughout the React application. So let me give you a quick demo of our website. Uh, so currently we are using a demo account, which is admin role. Sign in with your role-based demo account. So let's log in. After login, we first land on our inventory page. Our inventory module, each record is associated with an item, uh, location. Yeah. First, this is inventory module. Each inventory record is associated with an item location, and batch. Other than that, we have information such as physically available, reserved, and actually available. So let's make one inventory record. Other than that, we can also uh, apply filters on our locations and categories. For example, if I were to select a main operation hub, it will only show me locations that have main operation hub. So let's select control panel assembly main operation hub, stock in. Let's add 10 quantities, save adjustment. The save has done. As you can see, the control panel assembly in main operation hub has increased by 10, which was previously 95. It is now 105. So let's go to work orders. A work order contains location and item, the reserved quantity, and assigned user and status. When creating or viewing work orders, the system compares the required quantity with the available inventory at that location. So let's select our main operation hub, select control panel. Let's select 10 as a required quantity, add it to our admin. Let's create a work order. As you can see, the work order has been created. Let's start it. Uh, After starting, let's complete it. As you can see, it has been successfully completed. After work order, we have internal transfer page. Then transfer moves an item from source location to destination location and follows three stages: requested, dispatched, and received. When transfer is requested, inventory does not change. When dispatched, stock reduces. However, the destination location does not receive the stock immediately. Only when the transfer is marked as received is the inventory added to the destination location. So let me give you quick demo. Let's select main operation hub, destination regional distribution hub, and item control panel assembly. Let's select batch one and add 15 as a quantity. Request transfer. Let's dispatch it. Now let's see in the inventory. As you can see, previously it was 105. Now it is only just 90. And regional hub has also not received the uh, inventory changes. Let's mark it as a received. Now let's check inventory. As you can see, it has gone to 90, which was previously 75. So this works. Let's create a customer order reservation. Customer order reservation is created. The system validates available inventory before reserving stock. For example, if physical quantity is 100 and 30 units are reserved, only 70 units are available for the order. The reservation is performed inside database transaction to ensure inventory cannot be overused. So let's select Vaibhav. Let's select inventory record, which is control assembly in main operation hubs, which batch one, which currently has 90 available. Let's create order of 10. So the order has been created. The reservation has been created. Let's check it. So you can see that currently we only have 80 available. So all our modules in the application are working. Finally, we have profile which list a username of current user, their role and their email. So this was my submission to the case study. In this, we have covered our introduction, our architecture, technologies used, database schema. We have also covered APIs, their endpoints, errors. We have processed the uh, five main test cases and passed them all. I have showed you main course of my workflow. Other than that, I have given the working demo of my website. Um, Thank you for providing me with this opportunity. Uh, Thank you.